Hey, how's it going? So, we're just looking at some atmospheric complexities. I know, right? The equator has been undergoing a lot of tensors, if you haven't noticed. And maybe we can figure out some solutions to solve this atmospheric complexity we have here. Maybe. I don't know. So, so we look at some of the areas where it would seem more humid and are less humid, you know, where life is tending to maintain its permeability and vacuuming the chemical states and functions of the atmospheric cycle. Seems like everything's alright? Everything's okay. Oh, sorry. Well, if we would take a peek here, the equator is under a serious investigation of heat waves and turbulence. Most likely being impacted at the axis and or the angle of curvature. This is most likely the scorched traveling and the constant curvature effects of its path. As you can see, the more heated and elevated areas express some of the complexities of the heat waves and turbulence and are out of the axis, dealing with a lot of curvature equations. So it tends to be a lot of focus, most likely on the elements and a lot to do with chemistry. Per se, the environments are magical, and also the elements are magical, along with their locations. So we sorry, I'm really dehydrated. So we would see different types of things with the elements. You know, the axis is really interesting, along with how those elements became found. You know, they've been here since the beginning of time. And they also do a lot of things. This is the universal clock. The planet itself. Compacted it for its own resources. They're all byproducts. They're all different components, regions of electrons, make reactions at such wavelengths. Even conductances. But it's quite a magical field. You know, the Pacific Ocean and the Atlantic Ocean itself is pretty magical, along with the Indian Ocean. Then you have the North Pole and the South Pole, and everything in between, which of course is the equator. Well, a lot of the magic's never really discovered or explored. Why are the tectonics so different? Why are they radiative? I don't know. Nobody really tries to discover, tries to explore, to really know why. But the field is covered with various crystallized regions as above and below, along with the ocean too. So there's pretty much infinities of infinities. Since the ocean carries so much conductances, it's able to produce things at different rates. It's pretty much a conductor, no matter where we are on Earth, at just a different diffraction region. So therefore, be a strong generator of generating a charge and carrying it. So it requires the magnetic field produce it throughout curvature. So there's curvature metrics of like either clockwise and counterclockwise, north and south, or they either dual like a different manifolds in between. You know, it's quite the intensity if you think about it. There are different equations of motions. Sometimes quite the mystery of electrostatic. I don't know. I guess people don't really think about electrostatic that much, do they? I guess not. But me, on the other hand, I like to try to explore, try to discover why the crystal regions are around us inside of this magnetic field. Because inside of the magnetic field, chemistry would be endless, along with these regions, and where you can make different types of pressurizations, if it's including the ocean, or if it's including some sort of elevated region, where you can make different types of pressure state equations, you know, or decompressing. There's a lot of environmental things and environmental studies that we could do also with elements. It can be used for a lot of different things. We can also transform the planet with elements and with the planets. We can make a whole new world. We can maintain the planet. But, you know, making machines to either make biological clones and or rescaling the planet with reterritorizing our planes, reframing, rebuilding, restructuring, all the things that you can do with an intelligent system that's able to maintain the force and able to maintain the ocean. It would also help with our investigations of the atmosphere, because the atmosphere is our biggest equation, wouldn't it be? Well, seasonally and while the moon is constantly shifting, the moon's constantly been our biggest equation of motion, I think, per se, if you have some sort of sense of mind of watching some sort of gravitational system, therefore expressing quite a conundrum on the conductance in between itself, its gravity, and the presence of the moon. I mean, itself, its gravity, and the presence of the Earth. But, you know, either or vice versa, they're both gravitational systems, so they both sustain various waves and turbulence and or various excitations during the different solar phases, with different activity being as such a cluster of molecular nets that would therefore confine both of the north and south poles into some sort of electrical interaction of some sort, negative positive ratios corresponding to the molecular net charge of that charge ratio and the magnetic ratio. So the magnetic ratios therefore make some sort of dependence on finding or harnessing these different types of densities of charges per se, and the variations of their gravity. So the variations of gravity are strong because they make different types of conductances to different point-like particles. So together, the planet itself and the moon like fuel to each other with their gravity, because their gravity and their flux constantly intertwines. And magnetically, they can only make a charge ratio that will constantly make a clockwise or a counterclockwise motion in between. So it would be like spin up and spin down, which would, so one direction would go upwards and one direction would go downwards. We constantly see these motions through both of their superconductances throughout the solar phases, would express a lot of different geomagnetic storms. Therefore, had different types of magnetic interactions with the moon, and therefore had magnetic interactions with Earth, and apparently in between their gravity, they're like such a particle dynamic, and between the charged particles that they harness, and all the different types of excitational phases, what different types of plasma interactions, then it's therefore seen, therefore different types of gravitational interactions in between their gravities. So, it's been stored gravitational waves are therefore, like standing. So if there's like some sort of standing conductance here, they're like different durations of these standing charges. So, the standing charges would travel around. Sorry, I stretched my back. I was working. Ooh, my back keeps cramping up, but do need to keep moving myself. Yes, I do. I don't want to keep taking up your time. I was just talking about my investigations of the environments and why the ocean is a need itself, and restoring the ocean. What types of solutions would this have for all of us living on the land? And what types of solutions would it have for us if we were to rebuild the forest? And we can make many different machines where we can do things, where we could do things at accelerated rates. And I mean by accelerated, more accelerated than farms. But like we can, and not only while we're replanting, we can also make a cool water system with the environment, leading to different pathways that we can convert different types of saltwater systems into freshwaters. But we don't really want to use the freshwater systems. So if it's some sort of conversion system where we can store and harness different amounts and quantities, we therefore maintain doing massive architecture work and massive geology work, but we can therefore make shifts to the magnetic field with the balancing of different types of curvature equations using large bodies of water. But it would take a lot of math and understanding how the curvature effects happen with the charges of the Atlantic Ocean, the charges of the Pacific Ocean, and the charges of the Indian Ocean, and the other charges associated with the North and the South Pole. This itself is quite the mystery. Can you sustain the time to actually maintain a reference of some sort of given investigation that took place when all of these equations of motion, the atmosphere, the ocean, and various other things. So, I'm sorry again. I'm not trying to take your time. You can stay or go as you please.